Okay, a block of mass 5 is on a rough plane which is inclined at an angle of 15 to the horizontal as shown in the diagram below. The block is projected up the plane with a speed of 8, travels up the plane for 2 seconds before coming to rest momentarily. Show that the deceleration of the block is 4 meters per second. Okay, so because we have uniform acceleration, we can use the equation of uniform acceleration. So we can say that it starts, its final velocity is 0, its initial velocity was 8, it takes 2 seconds. If we use v equals u plus at, we get nothing equals 8 plus 2a, so a is going to have to be minus 4, so there is a deceleration of 4 meters per second squared because it's minus 4. Okay. Next thing we have to do is calculate the normal reaction. So first thing we're going to have to do is to draw ourselves a little force diagram. Okay, so there's our inclined plane. There's our block. Okay, so you've got a normal reaction at right angles to the plane. Now you've a weight force vertically down, but we normally resolve that into the weight forces component, which is 5g cos 15, and then acting down we have 5g sin 15. Now we were also told it was frictional rough, so there's also going to be a friction force which is equal to mu r, and we have a force that's being projecting it up the slope, and we'll call that F. Now because the block isn't moving off the plane, R must be equal to 5g cos 15. So R must be equal to 48. So it's equal to 48.3 newtons. Okay, so next we're asked, what's the frictional resistance? Well, we know F equals ma. Resultant force is equal to mass times acceleration. So we have acceleration is minus 4 and the mass is 5. And the resultant force is going to be the driving force up. There is no force acting up from the question, so we'll get rid of that force. So we have acting down, we have minus 5g sin 15 and minus the frictional force. Okay, so we have minus 20 equals minus 5g sin 15 minus the frictional force. So friction is 20 minus 5g sin 15. So friction force will equal 7.05904 4, so it's equal to 7.06 newtons. Okay, then we're asked to calculate the coefficient of friction. Because it's moving, we know friction is equal to mu r, or mu is the coefficient of friction. So we know then that 7.06 equals mu times 48.3. So mu is going to be 7.06 divided by 48.3. So mu, the coefficient of friction, will be equal to 146.127, so 0.146. Okay, now the last thing we're asked to do is calculate the acceleration of the block down the plane. Okay, we need a new diagram because it's now going to go down the plane, and when it's going down the plane, of course, friction always opposes motion. So we're going to have friction is going to go up the plane, and then down the plane we're going to have the weight force 5g sine 15. Okay, so F equals ma. So we're going to have 5g sine 15 minus the frictional force, which we know is 7.06, is equal to the mass times the acceleration. So that means the acceleration is going to be 5g sine 15 minus 7.06 divided by 5. So that's equal to 1.17638.092. That turns out to